What's up, world? My name is Dana Harris, and I'm single-handedly trying to make math cool again. And we're going to be talking in this series about the fractions portion of the fourth grade mathematics standards for the Common Core standards. So if you have a fourth grade student who is struggling once again with the also common fractions, a lot of people fear fractions. And it's not just young kids, it's old kids and even adults. So this series we're going to be talking about fourth grade fractions, and this particular lesson here I'm going to be talking about fraction equivalence. So establishing equivalent fractions. So let's go ahead and get right into the math. So let's say I'm going to draw a couple diagrams. So let's say I have this right here. Okay, and we're going to pretend all of these are the exact same size, although I know they're not necessarily. But work with me. And then I have room for one more. Okay, so boom, boom. Now notice all of these, I've broken them into two pieces. So I can see that's pretty crooked. Let's go ahead and do this so we can straighten that out. You see how I did that? That's much better. Make them look more of the same size. All right, cool. So I have this first one, and this has two pieces. So that means that if I shade right here, I'm going to get the fraction 1/2 because 1 out of 2 total parts are shaded in. Now, I want to take this second one and I'm going to make a different denominator. So if it has a different denominator, then that means it has more pieces, right? Say yes. All right, so it has more pieces. So let's go ahead and do 4 pieces. Okay, now, if I want to make a fraction that is equivalent or has the same value as 1/2, then I can simply do this. Okay, so I have 4 total pieces, but 2 of those are shaded in. Okay, if you notice, they cover up the same amount of space. So 1/2 is equivalent or equal to 2 out of 4. Moving to the next one, we're going to take that one and we want to break that one to even more pieces. So let's take this one and say, let's go 6 pieces. Okay, so we have 6 total pieces, so that means our denominator is going to be 6. Now, how many of those do I need to shade in order for it to be the same value as 2/4 or 2/4 and the same value as 1/2? Okay, well, you guessed it. So if I shade in tree out of these 6 pieces, then it's still going to be equivalent to 1/2. It's also equivalent to 2/4. If you notice, they have the same amount shaded. Okay, now I want to take this last one and let's make 8 total pieces. So we're going to take those 2, and then we're going to take those 2, and then we're going to take those 2. Now this one looks a little crooked to me, but we're going to pretend that they're all the same size. Nah, I can't do it. I'm sorry. I gotta erase this. It's irking me. So we've redrawn our piece with the eighths, or our model with the eighths, because it just wasn't looking right. So now I have 8 total pieces, and so my denominator is going to be 8. So how many of those do I need to shade in order for it to be equivalent to 3/6, 2/4, and 1/2? We know 1/2 is the one that we started with. So we want, how many eighths does it take to be equivalent to 1/2? Well, I think you guessed right. All right, so if we shade in 4 out of 8 pieces, then we will have the same value as 1/2. It's also the same value as 2/4. It's also the same value as 3/6. Okay? So, with that being said, now we know how to create equivalent fractions using a visual model. The thing we want to do now is we want to create we want to be able to create equivalent fractions. Let's say, what if we didn't have a visual model? And if we didn't have a visual model, that would create some problems for us. And let's see, let's get this stuff real clean real quick. It's clean enough. So if we didn't have a visual model, then one thing we can use is the big one, as I like to say. So let's go ahead and let's start with 1/2 again. Well, no. Let's do 1/4. Okay, so if I have 1/4. Now, if I multiply this, we've learned that anytime you multiply something by 1, it equals to whatever you started with. So if I have 5 times 1, I get 5. If I have 7 times 1, I get 7. So if I have 1/4 times 1, then I'm going to get 1/4. But we're going to put a little twist to that. Remember, if we have a fraction with the same numerator and denominator, it's equivalent to 1. So let's say I have 2/2, which 2/2 is equivalent to 1. That's why I have the big 1 there. So if I multiply 1 times 2, I get 2. If I multiply 4 times 2, I get 8. So 1/4 and 2/8 have the same value. Let's try that again. We're going to start with 1/4 again. And I'm going to multiply it by the big 1. All right. Let's do 3/3 or tree/tree. And I get 1 times tree is tree. 4 times tree is 12. So that tells me that 3/12 is also 1/4. Okay? One more. Once again, starting with 1/4. And we're going to multiply it by the big 1. As you guys can see, I'm not the greatest artist. All of my ones look different. Let's go. We're not going to go to 4. We're going to say 6/6. Once again, 6/6 has a value of 1. Tree/tree has a value of 1. 2/2 has a value of 1. Okay? We will get 1 times 6 is 6. 4 times 6 is 24. Guess what? That is another example of equivalent fractions. So 1/4 is equivalent to 6/24. 1/4 is equivalent to 2/8. 1/4 is equivalent to 3/12. And there's several other examples that we can use that have an equivalence or an equal value. So I know I'm using big words for you, but equivalence, the root word is equal. So that just means that these two fractions have the same value. They may look different. They have different numerators. They have different denominators, but they have the same value. Young Guru's Math Tutoring. I've got the solution to your math problem.